What if the nearest galaxy was not just our neighbor, but our future mother? The question hovers in the night sky like a secret. Step outside on a clear evening, away from the glare of cities, and let your eyes adjust to the dark. If you are patient, you may catch it. Just above the horizon, a pale, ghostly smear, faint and shy. Many people never notice it, even after years of looking at the heavens. But there it is, the Andromeda Galaxy, our nearest great neighbor in the cosmos, a silent companion, vast and luminous, suspended across 2.5 million light-years of empty space. To see it is to gaze not at a star, but at a city of 1 trillion suns. For much of human history, no one knew. To the first skywatchers, Andromeda was simply a smudge of light, no different from the cloudy bands of the Milky Way itself. Ancient astronomers recorded it as a little cloud, something delicate, almost decorative, as if it were an ornament pinned to the black velvet of the heavens. Even into the early 20th century, many believed that was all it was, a nebula, a fog of glowing gas drifting within our own galaxy. The thought that it might be something larger, a colossal structure beyond imagination, seemed too extravagant. But sometimes the universe hides its most astonishing truths in plain sight. That faint blur was not a cloud within our home. It was another home entirely, a separate island of stars, spinning far beyond the borders of the Milky Way. To realize this would require a struggle, a debate so intense that it reshaped astronomy itself. It would take place not in the dark of night with telescopes, but in lecture halls and printed journals, where arguments collided like stars. The moment is remembered today as the Great Debate, and in its echoes, we hear the universe expanding before us. The year was 1920. The place, Washington, D.C. The stage was the Smithsonian Museum of Natural History, and the question was deceptively simple. How large is the universe? On one side stood Harlow Shapley, a young and ambitious astronomer. He believed the Milky Way was the entirety of the cosmos, a vast but self-contained structure stretching a few 100,000 light-years across. The spiral nebulae that dotted the sky, including Andromeda, he argued, were merely small clouds of gas embedded within our galaxy's borders. Facing him was Heber Curtis, older, sharp, and equally determined. Curtis had been studying the spiral nebulae, and he was convinced they were not clouds at all, but galaxies in their own right, what he called island universes. To him, Andromeda was not a nearby mist, but a distant metropolis of stars, millions of light-years away, so far that its individual suns blurred into a pale haze. The debate raged for hours. Each side presented evidence, each raised objections. Shapley pointed to the apparent size of the Milky Way, to the distribution of globular clusters, and to the limits of observable stars. Curtis countered with the sheer brightness of novae observed in Andromeda, arguing that no nebula within the Milky Way could possibly shine so strongly without being destroyed. Back and forth they went, their words like cosmic chess pieces, moving across the board of the universe. In the end, no winner was declared. The audience dispersed, the newspapers printed summaries, and the cosmos remained unsettled. For a time, it seemed the universe could not be decided by debate alone. But science does not end with arguments. It continues with observation, with patient nights under the stars, with instruments that pierce deeper than human eyes ever could. And it was one quiet observer, working in California a few years later, who would finally tip the balance. Edwin Hubble was his name, and his tool was the Great Telescope at Mount Wilson Observatory. With it, he examined Andromeda in exquisite detail, searching its light for clues. What he found were Cepheid variable stars, stars that rhythmically brightened and dimmed, each pulse like the tick of a cosmic clock. Henrietta Swan Leavitt had shown years earlier that the rate of their pulsing could reveal their true brightness. By comparing their intrinsic glow to their apparent dimness from Earth, astronomers could measure distance across the void. Hubble did the calculations, and what emerged was staggering. The Cepheids in Andromeda were far, far too distant to be part of the Milky Way. They lay millions of light-years away. The blurred cloud was not a nebula at all, but an entire galaxy, rivaling and even surpassing our own in size. In one stroke, the universe expanded from a single island to an archipelago without end. The cosmos was not just our home, it was filled with countless other homes, each with its own story, its own history, its own possibilities. This discovery was more than a correction of maps. It was a psychological earthquake. For generations, humanity had thought itself central, even when astronomy revealed Earth as a planet orbiting the Sun, and the Sun as one star among billions. But to learn that the Milky Way itself was not the whole, that it was only one among many galaxies, was to feel the floor give way beneath us. Imagine thinking you lived on the entire continent, only to discover you were on an island, and across the sea lay thousands more, stretching to the horizon. The ocean was not empty, it was full. Andromeda became not just an object of curiosity, but a symbol. It stood as proof that the universe was larger, stranger, and more generous than anyone had dared to dream. Every faint nebula in the sky, once thought to be a wisp of local gas, might be an entire galaxy of its own, a city of stars floating in the dark. Hubble's work did not just resolve a debate, it opened an era. Modern cosmology was born in the light of Andromeda's stars. And yet, even in this expansion of scale, there was something profoundly intimate. To look at Andromeda is to look at a galaxy visible to the naked eye, a vast city shining across a gulf of millions of years. Its light left long before humanity existed, before mammals walked the Earth. When those photons began their journey, there were no eyes to see them, and yet they traveled faithfully across the ages, crossing intergalactic space, slipping between dust and gas until they fell at last into a human retina. In their glow, we saw not only a galaxy, but a reflection of ourselves. Curious, questioning, forever reaching outward. And so the faint blur in the sky became a doorway to other galaxies, to the vastness beyond. Once we knew Andromeda was not a mere mist, the question shifted. What was this colossal neighbor made of? What secrets lay hidden in its spirals, its stars, its heart of darkness? To peer into Andromeda was no longer to glance at a cloud, but to begin a journey into the architecture of the universe itself. When we speak of Andromeda, it is easy to forget just how immense this neighbor truly is. We may call it a galaxy, but that word is too small, too fragile to hold what it represents. Andromeda is not merely larger than the Milky Way. It is nearly twice as wide, a sprawling spiral stretched across 200,000 light-years of space. Within it shine about 1 trillion stars, each one a nuclear fire, each one a sun. The number is almost meaningless to say aloud, a trillion. It drifts past the ear like a riddle. But pause and try to picture it. Every star you can see in the night sky, every glimmer of starlight overhead is part of our own Milky Way. A few thousand are visible to the naked eye. A few 100 billion exist in total. Andromeda contains more than double that. It is as though the sky itself has a hidden reservoir, a secret library of stars, waiting in silence just beyond our reach. Imagine stretching out that luminous disk, a spiral so wide that light itself would take more than 200,000 years to travel from one side to the other. From Earth, it appears as a faint smudge, yet if your eyes were sharp enough, if your vision could magnify without end, you would see structure within structure, like patterns within seashells. You would see its glowing core, dense and golden, the crowded heart of the galaxy where ancient red stars orbit in slow, stately paths. Around it, vast spiral arms unfurl, curling outward like ribbons, alive with dust and gas, where newborn stars shine with a youthful blue brilliance. The contrast is striking. The core is old, filled with stars that have burned for billions of years, their light softer, redder, cooler, like embers fading in a hearth. The arms, in comparison, are restless nurseries, glowing with hot, short-lived giants that blaze fiercely before dying young. Within those arms, clouds of hydrogen collapse under their own gravity, kindling nuclear furnaces, giving rise to clusters of stars that will scatter like sparks. Andromeda is both elder and nursery, memory and birth, a galaxy that remembers its ancient past while constantly refreshing itself with new generations of light. It is tempting to think of Andromeda as static, as if its spirals were fixed like a painting, frozen in place. But galaxies are living, dynamic systems. Stars orbit its center, gas flows, dust thickens and disperses. Over millions of years, its arms twist and shift, reshaped by gravitational tides and collisions with smaller galaxies. Every star we see within Andromeda is in motion, each following its own path in a vast celestial dance. If you could watch the galaxy in fast motion, speeding up billions of years, you would see it whirl and shimmer like a whirlpool of fireflies. And within this whirlpool, each point of light is not a solitary object, but a system, often with planets, moons, asteroids, and comets. The imagination stumbles here. To think of 1 trillion suns, and then to think that many of those suns may carry their own families of worlds, is to enter a scale beyond comprehension. The disk of Andromeda is not just a flat sheet of light, but a depth-filled cosmos, layered and complex, brimming with possible worlds. There may be planets with oceans of water, planets of ice, planets shrouded in storm, planets warmed by twin suns, planets buried beneath layers of cloud. Most of them we will never see, not in our lifetimes. But they exist, quietly orbiting in the dark, the byproducts of stellar birth, each carrying its own story in silence. If we step back and consider its sheer immensity, Andromeda forces us to rethink scale itself. The human brain is not built to grasp such distances or such numbers. We measure our lives in decades, our histories in millennia. 1,000 years feels long, and yet it is a blink to the stars. A light year, the distance light travels in a year, already stretches our imagination. Multiply that by 200,000, and you arrive at the width of Andromeda. Multiply by 2.5 million, and you reach the gulf between it and us. These numbers are so vast they escape ordinary meaning. They are not statistics, but thresholds of thought, gateways into wonder. Every star we see tonight belongs to our local neighborhood. Every constellation is carved from Milky Way light. Orion, Cassiopeia, the Big Dipper, they are parochial stories, small arrangements of nearby stars. Andromeda is the reminder that beyond those familiar shapes lies an abundance of light greater than anything we can count. 1 trillion suns, hundreds of billions of planets. The mind recoils, but also marvels. We are small, yet we are aware, and that awareness connects us to the immensity. Perhaps what makes Andromeda most astonishing is not its distance or its number of stars, but its visibility. This entire structure, this cosmic metropolis, can be glimpsed without a telescope, faint but real, hovering in the night. When you look at it with the naked eye, you are seeing the combined glow of 1 trillion suns smeared into a blur by distance. No photograph, no telescope, no diagram can fully capture what it means that such immensity can be folded into a single point of human vision. It is like seeing a mountain compressed into a grain of sand. Andromeda is the nearest great spiral galaxy, but it is not the only one. The universe contains billions of galaxies, each unique in shape and size, each a separate story. Yet Andromeda is special because it is close, because it shares space with us in the local group, because one day it will merge with our own galaxy. Its spirals are not just an abstraction in a textbook. They are our neighbors' streets, the avenues of light we will one day cross. Somewhere in that trillion-fold expanse, there may be stars with planets orbiting at the right distance, warmed just enough to harbor liquid water. Somewhere in that sprawling disk, there may be life, fragile but tenacious, evolving in seas beneath alien skies. Whether simple microbes or civilizations with thoughts of their own, we cannot know. But the possibility lingers in every shimmer of light, every pulse of starlight from Andromeda's arms. We often forget how much is hidden in what seems ordinary. That pale smear of light in the sky looks small, yet it contains abundance beyond reckoning. It teaches us humility, but also wonder. It reminds us that the universe is not empty, but filled, overflowing with light, with possibility, with sheer existence. And yet, even this immensity, even this trillion-fold blaze of stars, is not the whole truth. For Andromeda has more weight than its visible stars can explain. Something unseen is binding it together, holding its spirals in place, preventing them from flying apart. The stars alone are only half the story. The rest lies in the shadows. Andromeda is vast, luminous, and alive with 1 trillion stars. Its spirals sweep outward in graceful arcs, as though painted across the canvas of the cosmos. Yet here lies a puzzle. If we calculate the gravitational pull of all its visible stars, its clouds of gas, its clusters of ancient suns, we arrive at a disturbing truth. It is not enough. The galaxy spins too quickly. Its outer arms move faster than the gravity of the stars alone should allow. By all ordinary accounts, Andromeda should be tearing itself apart, flinging stars and dust into intergalactic space, unraveling like a loose thread. And yet it holds together. Its arms remain intact, its core remains centered, its vast disk continues to whirl with patient stability. Something is missing from our view. Something invisible must be binding the galaxy together. This something is what scientists call dark matter. The name is simple, perhaps deceptively so, but the mystery is profound. Dark matter does not glow. It does not reflect. It does not absorb light in any measurable way. To every telescope ever built, it is invisible, and yet its presence is undeniable, revealed only through gravity, the universal language of mass. Andromeda, like every galaxy we know, is wrapped in a halo of this unseen substance, a ghostly lattice that outweighs all the visible stars combined. If the stars and gas are the flesh of Andromeda, then dark matter is its skeleton, the scaffolding upon which the galaxy rests. Without it, the spiral would dissolve. With it, the spiral endures. The discovery of dark matter was not a sudden revelation, but a gradual suspicion, a whisper that grew louder across decades. In the 1930s, Fritz Zwicky, an eccentric Swiss astronomer working at Caltech, studied the motions of galaxies in the Coma cluster, a swarm of hundreds of galaxies bound together. He noticed that the galaxies moved far too fast for the amount of visible mass present. By his calculations, there had to be hundreds of times more matter than what could be seen in stars. He called it dunkle materie, dark matter. His colleagues largely ignored him. Zwicky was brilliant but abrasive, and his ideas often seemed outrageous. Yet time would prove him correct. In the 1970s, Vera Rubin, an astronomer who worked in quiet determination, turned her attention to spiral galaxies, including Andromeda. She measured how quickly stars orbited at different distances from the galactic center. If the galaxy contained only the mass of its visible stars, then stars at the edges should orbit more slowly, just as planets farther from the sun move more gently around it. But Rubin found something astonishing. The stars at the edges were moving just as quickly as those near the center. The rotation curve was flat. The implication was inescapable. Some unseen mass was present, exerting gravitational influence, keeping those fast-moving stars bound. Andromeda became one of the clearest examples. Its stars, gas, and dust could not explain their own motion. Around it must exist a vast halo of invisible matter, spherical, diffuse, and yet more massive than all the luminous matter combined. It was as though Andromeda was draped in a cloak of shadows, unseen but indispensable. What is dark matter made of? That remains one of the greatest unanswered questions in physics. It cannot be ordinary matter, atoms, protons, electrons, because those interact with light, and we would have seen them. Instead, it must be something else, something beyond the familiar particles of the periodic table. Some propose exotic particles like WIMPs, weakly interacting massive particles, or axions, hypothetical particles predicted by certain theories. Others suggest entirely new physics, hidden dimensions, or modifications to gravity itself. Decades of experiments have sought to capture a trace of dark matter on Earth, building detectors deep underground to shield them from cosmic rays, waiting for a whisper of interaction. So far, the detectors remain silent. Dark matter continues to elude us, invisible and untouchable, yet all around us, all through us. To think of Andromeda's dark matter halo is to imagine a sphere of substance stretching hundreds of thousands of light years beyond its visible stars. The galaxy we see, the luminous spiral, is only the tip of the iceberg, a bright filament floating within a vast, transparent sea. The halo is not sharp-edged but diffuse, fading into intergalactic space. Its particles, whatever they are, pass through ordinary matter without resistance, like ghosts through walls. Even as you sit here listening, trillions of dark matter particles may be streaming through your body, unnoticed, unfelt, their presence silent and mysterious. And yet, without them, there would be no galaxies at all. Cosmologists believe dark matter was essential in the earliest epochs of the universe. After the Big Bang, matter was spread almost evenly, but tiny fluctuations in density began to grow under gravity. Ordinary matter, interacting with light, was too restless, too easily scattered. But dark matter, invisible and indifferent to radiation, clumped together, forming the first gravitational wells. Into these wells, gas and dust fell, cooling, condensing, and eventually igniting as stars. In this view, dark matter was the scaffolding upon which the first galaxies assembled, the hidden architecture of cosmic history. Without dark matter, there would be no Milky Way, no Andromeda, no stars, no planets, no life. Andromeda's beauty, its trillion suns, its glowing arms, its promise of worlds, all rest upon something we cannot see. That is the paradox. Dark matter shapes the visible universe while remaining forever invisible. It is the stage upon which galaxies dance, yet it never appears in the spotlight. It is a silence that sustains the symphony. For some, this is a source of frustration. To build theories upon something unseen, to trust gravity's whisper over light's evidence, feels like chasing a shadow. But perhaps there is something poetic in it. The universe reminds us that not everything that exists must be visible. Not everything that matters must shine. Just as thoughts and dreams shape human life without being seen, so dark matter shapes the cosmos, silently holding the stars in place. Imagine Andromeda without it. The spiral arms, already fragile, would lose their cohesion. The outer stars would fly free, drifting into intergalactic night. The galaxy would disintegrate, its structure unraveling. The beauty we admire through telescopes would dissolve into chaos. Dark matter is not an ornament. It is the glue that holds the galaxy together, the skeleton that allows its luminous flesh to move as one body. To gaze at Andromeda is therefore to gaze at both presence and absence. We see the light of stars, the brilliance of clusters, the glow of nebulae. But behind them, around them, enfolding them, lies an unseen halo, silent and immeasurable. It is as though we are looking at a cathedral lit by candles, yet the entire structure rests upon invisible stone. The mystery of dark matter is far from solved. It may be decades before we understand it, or centuries, or perhaps never. But its reality is undeniable. Andromeda whispers it with every rotation, every orbit of stars too fast to be explained by light alone. It reminds us that the universe is not only stranger than we imagine, it is stranger than we can imagine. And so, in Andromeda's spiral, we find a paradox. The most visible galaxy in our night sky depends utterly on the most invisible substance in the cosmos. Its beauty is framed by shadow, its stability given by absence, its existence owed to something we cannot see. And if dark matter is the skeleton, the hidden bones of the galaxy, then the natural question arises, what lies at the heart? At the heart of every great city lies a center, a place where roads converge, where life organizes itself around a hub. For galaxies, that center is rarely calm. Beneath the swirl of stars, at the very axis of rotation, there often lurks a presence of unfathomable weight. In Andromeda, this presence is a sleeping giant, a supermassive black hole more than 140 million times heavier than our Sun. Its official designation, M31 may sound clinical, but what it represents is anything but. It is a cosmic abyss, a place where space folds inward and time itself bows, a region where gravity becomes so absolute that nothing, not even light, can escape. From Earth, we see no dazzling beacon at Andromeda's center. The black hole is quiet, its appetite long diminished. Unlike the monstrous quasars that once blazed across the early universe, outshining entire galaxies, M31 Sturi emits little more than a whisper of radiation. It is dormant, a sleeping predator that has eaten its fill, yet its silence belies its power. The stars that orbit close to the galactic center dance under its sway, circling as though tethered to an invisible anchor. This anchor defines the very geometry of Andromeda's core, shaping the orbits of millions of stars. But was it always so quiet? Evidence suggests otherwise. Astronomers believe that billions of years ago, M31 Sturi may have been far more active, a voracious eater of stars and gas. In those ancient epochs, streams of matter may have spiraled inward, heating to unimaginable temperatures as they fell across the event horizon. If so, Andromeda's nucleus would once have blazed like a lighthouse, its radiation visible across millions of light years, a cosmic torch in the dark. Galaxies across the cosmos might have glimpsed Andromeda not as a faint spiral in the night, but as a quasar, a celestial bonfire burning with the hunger of its central giant. The story of black holes is the story of hunger. They grow by devouring, by consuming stars that wander too close, by swallowing gas clouds that drift into their reach, by merging with other black holes in cataclysmic unions. In this way, they are both destroyers and builders. The energy unleashed by their feeding shapes galaxies, blowing winds that can quench star formation or ignite it anew. In the early universe, the brightest galaxies were those with the hungriest black holes, their cores lit by matter spiraling to its doom. But hunger does not last forever. Eventually, the larder runs dry, the fuel is spent, and the giant falls into slumber. That is where we find Andromeda's black hole today. Quiet, waiting. its immense gravity undiminished but its appetite restrained. Yet silence does not mean absence. Around the galactic center, stars still bear scars of close encounters. Some move at extreme speeds, their orbits slingshot by the black hole's pull. Others may have been torn apart entirely, their fragments heated into streams of plasma before vanishing into darkness. The remains of these cosmic meals are not easy to detect, but astronomers search for subtle signatures, faint X-ray flares, sudden brightening that betrays a brief feast. M31 SAR may be quiet, but it is never harmless. And it is not alone. Throughout Andromeda's spiral arms, smaller black holes almost certainly wander. Some may be the remnants of massive stars that collapsed at the end of their lives, stellar black holes weighing 10 or 20 times the mass of the Sun. Others could be intermediate in scale, thousands of solar masses, formed in the collapse of ancient clusters. These hidden predators drift silently through the galaxy's seas of stars, invisible except when chance allows them to feed. To imagine Andromeda is not only to imagine its trillion suns, but also to imagine countless unseen abysses scattered among them, quiet but waiting, each capable of consuming anything that comes too close. It is tempting to think of a galaxy's center as its soul, a reflection of its inner nature. If so, Andromeda's soul is one of hunger, tempered by time. The black hole at its heart once raged with appetite, transforming its nucleus into a beacon. Now it rests, content, a giant whose hunger has been quenched. But this state is not permanent. The history of galaxies is a history of change, of mergers and collisions, of matter flowing inward and outward. The slumber of M31 SAR may one day be broken, its silence shattered when new fuel is delivered to its doorstep. This possibility raises unsettling questions. What would it take to awaken Andromeda's giant mass? A passing gas cloud could drift too near, torn apart and consumed, releasing a flare that would briefly light its core. Or perhaps, when Andromeda and the Milky Way collide in billions of years, rivers of matter will funnel inward, reigniting the black hole with fresh sustenance. In that far-off future, M31 SAR may roar once more, growing even larger, blazing with radiation. In time, it may merge with our own central black hole, Sagittarius A star, combining to form a still greater abyss at the heart of the new galaxy born from their union. But that is a story for another chapter. For now, Andromeda's giant slumbers. Its silence is a reminder that the universe contains not only the luminous and the visible, but also the hidden and the waiting. Its existence is both threat and anchor, a paradox of destruction and stability. Without it, the motions of stars in the core would lack their organizing center. With it, the galaxy gains both structure and a latent danger. It is a presence that embodies both creation and annihilation, order and hunger. For humanity, the contemplation of black holes is a lesson in humility. We live in a cosmos where the most massive, most influential entities are invisible, where the beating heart of a galaxy is an abyss. To think of M31 SAR is to realize that beauty is often defined by contrast, that light acquires meaning only in the presence of shadow, that a spiral galaxy's radiance depends upon a dark center that consumes everything it touches. Perhaps that is why we are drawn to them. Black holes represent the limit of our understanding, places where our laws of physics falter, where time and space are no longer distinct, where questions multiply faster than answers. In the stillness of Andromeda's center, we glimpse not only a sleeping giant, but also the edge of human comprehension. And so, when we gaze at Andromeda through telescopes, we are not just looking at a swirl of stars. We are also looking at silence, at hunger, at an abyss 140 million times more massive than the Sun, an abyss that shapes the galaxy without ever being seen. It is both the most terrifying and the most essential feature of Andromeda, a paradox we are still learning to accept. But galaxies are never static. They evolve, they collide, they carry scars of what they have endured. And if we look closely at Andromeda, past the spiral arms and the sleeping giant at its core, we can begin to read those scars, to trace the history of its wounds. Every empire, no matter how vast, has its satellites. Great cities gather villages at their edges. Kingdoms draw smaller territories into their orbit, and galaxies are no different. Around Andromeda, faint companions drift, dwarfs so fragile that many are only barely holding themselves together. Some shine as dim smudges against the black, while others are nothing more than threads of stars, unraveling like frayed cloth. These are Andromeda's companions, its witnesses, and its casualties. Among the brightest of these is M32, a compact little galaxy clinging close to Andromeda's side. To the naked eye, it would hardly warrant notice, a faint smear overshadowed by its colossal neighbor. Yet M32 is unusual, for it has been stripped bare. Astronomers believe that once it was larger, a respectable elliptical galaxy in its own right. But Andromeda's gravity tore away its outer layers, peeling off stars and gas until only a dense, bright core remained. Today, M32 resembles a survivor, reduced but enduring, a reminder that proximity to greatness can also mean destruction. Nearby is M110, another dwarf elliptical, softer, more diffuse, a cloud of ancient stars drifting in orbit. Unlike M32, it retains more of its body, but it too shows scars of Andromeda's pull. These two companions are only the most visible of dozens. Andromeda is surrounded by an entourage, an extended family of faint dwarfs and satellites, each with its own story, each trapped in the gravity of the spiral giant. Some are still intact, quietly circling like moons around a planet. Others have already begun to disintegrate, stretched into long rivers of stars, stellar streams that wrap around Andromeda like ghostly ribbons. These streams are more than ornaments. They are the fossil record of violence. Each one is the remnant of a smaller galaxy torn apart and consumed, its stars redistributed into Andromeda's halo. When astronomers map these streams, they are reading the galaxy's diary, tracing the entries of ancient conquests. Here lies the memory of a dwarf that strayed too near. There stretches the trail of another that was unspooled into the night. To study them is to understand that Andromeda is not only a majestic spiral, but also a predator. If the dwarfs are the living companions, then the globular clusters are the relics. More than 500 of these swarm around Andromeda, each one a tight knot of ancient stars. They are among the oldest structures in the universe, spheres of suns that formed when galaxies themselves were young. To peer at a globular cluster is to look back across billions of years to glimpse a fossil of the cosmic dawn. Andromeda's great population of these clusters tells us that it has been active for a long time, growing by mergers, gathering material, building its empire. Each cluster is a survivor of those early days, a time capsule suspended in orbit. It is tempting to think of Andromeda as a kind of celestial city-state, with its core as the palace, its spiral arms as the streets, and its dwarfs and clusters as the surrounding villages and monuments. But that image, though poetic, is incomplete. For unlike a city, Andromeda's companions are not merely dependent. They are consumed. The galaxy's gravity is relentless, always drawing, always stripping, always incorporating. To orbit Andromeda is to risk dissolution. Over time, the Empire grows not only by holding its companions, but by devouring them. This duality, guardian and destroyer, ruler and cannibal, is part of what makes galaxies so haunting. Andromeda's halo is filled with the evidence of its appetite. Every shredded dwarf, every elongated stream, every faint arc of stars is a memorial to something that once was whole. In that sense, Andromeda is as much a graveyard as it is a kingdom. Its grandeur is built on absorption, its beauty on the remnants of the conquered. For astronomers, this truth is invaluable. By studying Andromeda's companions, they glimpse processes that shaped not only this galaxy, but also the Milky Way. Our own galaxy, too, has its retinue of dwarfs, many of them showing signs of disintegration, and globular clusters that mark the epochs of its formation. To look at Andromeda is to hold up a mirror, to see a version of our own future and our own past. We are not alone in being empires of conquest. This is how galaxies grow, by gathering, by colliding, by consuming. The cycle is universal. And yet, despite this violence, there is a strange intimacy to the relationship between Andromeda and its companions. These dwarfs are faint, yes, but they orbit for billions of years, loyal until the end. Some may survive until the great collision with the Milky Way, swept into the chaos of that event. Others will be long gone by then, their stars already absorbed, indistinguishable from the larger body of Andromeda. Their fate is sealed, but their story is eternal, written in the streams of light that lace the night. Take a moment to imagine what it would feel like to live in one of these dwarfs. From such a vantage, Andromeda would dominate the sky. Its spiral arms would stretch across the heavens, a luminous giant filling your night with patterns of light. To live in a satellite galaxy is to exist under the gaze of something incomprehensibly vast. To orbit not just a body of stars, but a presence. One might feel both awe and inevitability, knowing that the pull of the giant shapes every motion, every future. Andromeda's companions remind us that nothing in the universe stands apart. Even the small are bound to the large. Even the fragile contribute to the strength of the mighty. Galaxies are not isolated jewels floating in darkness, but families, networks, empires of light and gravity. The faintest dwarfs, barely visible through telescopes, are no less part of the story than the trillion stars of the spiral itself. They are the context, the evidence, the whispers of history. And so, when we speak of Andromeda, we do not speak of a solitary being. We speak of a collective, a constellation of companions, an empire sustained by both loyalty and conquest. It is both the mother and the devourer of its satellites, a ruler who embraces and consumes. In this way, Andromeda becomes not just a galaxy, but a narrative of power, of fragility, and of the cycles that define the cosmos. Yet sometimes the story of destruction does not unfold in the slow pull of gravity, stretched across eons. Sometimes it happens all at once, in a sudden burst of light, when a single star ends its life in an instant of unimaginable violence. If the satellites and clusters are the quiet reminders of Andromeda's appetite, then these explosions are its fireworks, brief and terrible, painting scars across the spiral arms. In the summer of 1885, astronomers peering through their telescopes toward Andromeda witnessed something extraordinary. For centuries, the faint blur of this galaxy had been known as a quiet smudge in the sky, unchanging, serene. But suddenly, a new light appeared near its center, one so intense that for a brief time it outshone all the billions of stars combined. Observers from across the world recorded it, unsure of what they were seeing. This was SN 1885A, the first supernova ever identified outside the Milky Way, and it was a revelation. Imagine standing beneath the night sky of that year. You gaze upward, and in the familiar haze of Andromeda, a strange new star blazes forth. At first glance, it seems impossible, for galaxies appear immutable to human eyes, their vastness ensuring that nothing about them should change on such short timescales. And yet, here was a stellar death so violent that it reached across 2.5 million light-years, its aftershock carried by photons that had been traveling since before humanity dreamed of the telescope. By the time those photons touched Earth in 1885, the star that created them had long since ceased to exist. A supernova is both an ending and a beginning. In its final moments, a massive star burns through the last of its nuclear fuel, iron building in its core like lead weights in a sinking ship. The equilibrium that held it together collapses, and in less than a second, the star implodes under its own gravity. The rebound is catastrophic. In a titanic explosion, its outer layers are hurled into space at a fraction of the speed of light. What remains may be a neutron star, dense enough to pack a mountain into a teaspoon, or a black hole, so compact that no light escapes. But the ejected debris carries something priceless, elements forged in the crucible of stellar death. It is here that the story turns intimate, for these ashes are the very building blocks of us. Supernovae scatter carbon, oxygen, iron, calcium, and countless other elements into the galaxy. Without them, there would be no rocky planets, no oceans, no bones, no blood. Every atom of iron in your body was once inside the heart of a star that died like this. Every breath you take, rich with oxygen, is a gift from long-dead suns. In Andromeda, just as in the Milky Way, these explosions seeded the spiral arms with the ingredients for new generations of stars and planets. A supernova is not merely destruction, but transformation. SN 1885A, as bright as it was only one of countless such events scattered through Andromeda's history. Though few are seen directly, their remnants remain. Clouds of gas, laced with heavy elements, expand outward, glowing faintly as they are heated by shockwaves and cosmic rays. These remnants are like scars in the galaxy, echoes of moments when stars ended violently, reshaping their surroundings. They are also like gardens, for it is within these enriched clouds that new stars form. The cycle of life and death in the cosmos depends on this recycling. Without supernovae, galaxies would stagnate, trapped in eternal repetition. With them, they become fertile, ever-renewing landscapes. Astronomers studying Andromeda have identified dozens of these remnants, each one a kind of fossil in light. Some are circular shells, delicate and ghostly, drifting across the dark like luminous smoke rings. Others are jagged and chaotic, twisted by turbulence and magnetic fields. Each remnant carries within it a record of the explosion that birthed it, a memory of violence encoded in shape and composition. By examining these structures, scientists can reconstruct what happened, piecing together the final moments of the star and the impact it had on its surroundings. The meaning of these explosions extends beyond science. To look at a supernova remnant is to contemplate impermanence. Stars that shine for billions of years can end in seconds, their light extinguished in a blaze. What feels eternal is often fragile, and yet from this fragility comes creation. We live in a universe that requires destruction for renewal, a place where endings are not final, but transitional. The atoms in our bones remind us of this. We are, quite literally, the children of death and fire. There is also something humbling about the scale. The supernova of 1885 was visible only faintly to the human eye, but in Andromeda itself, had there been watchers on nearby worlds, the sky would have changed utterly. A star that once shone steadily would have erupted into brilliance, casting shadows across their landscapes, burning so brightly that even day could not hide it. For them, it would have been a terrifying spectacle, a reminder of the fragility of suns. For us, it was a whisper across the void, a faint glimmer that challenged our sense of permanence. Even today, the ghost of SN 1885A lingers. Modern telescopes can still detect its remnant near Andromeda's core, a faint stain of iron and calcium spreading through the interstellar medium. It is easy to pass over in the images, overshadowed by the grandeur of the galaxy's spiral arms. Yet, in that faint smudge lies the story of renewal. Stars that will one day form planets, perhaps even life, will inherit the ashes of that explosion. The lesson of Andromeda's supernovae is that galaxies are not only collections of stars, but also crucibles of transformation. Their grandeur is built not just on light, but on fire and ashes. To map the spiral arms is to map both the living and the dead, both suns shining today and those that ended long ago. We often think of galaxies as serene swirls, but they are more like battlegrounds, filled with violence that shapes creation. Take a moment to let this sink in. The atoms you carry were once part of stars that exploded billions of years before Earth existed. You are a continuation of those explosions, their remnant incarnate. To look at the fire scars in Andromeda is to see your own ancestry in cosmic form. It is to remember that destruction and creation are inseparable, that the universe writes its story not only with light, but with endings. But not all endings are so sudden. Not every star dies with such violence. Some prefer a gentler rhythm, fading rather than erupting, pulsing softly in cycles of brightness and dimness, whispering their mortality instead of shouting it. These stars are like cosmic metronomes, steady, reliable, a heartbeat echoing across the spiral arms. They remind us that the universe is not only made of fire, but also of rhythm. And if we listen carefully, Andromeda begins to reveal this quieter song. If you were to gaze long enough at Andromeda, you might believe its light is steady, unchanging, like a lantern hung in the blackness of space. But look more closely, and a different truth emerges. Within its trillion stars are countless subtle flickers, delicate pulses of brightness and dimness, some lasting days, others hours, some stretching across weeks. These are variable stars, suns that do not shine with a constant light, but instead beat like hearts, expanding and contracting, whispering their rhythms into the dark. Among the most famous of these are the Cepheid variables, the great pulsators. A Cepheid is not an ordinary star, but one caught in a kind of cosmic instability. Its outer layers swell outward and then collapse inward, over and over, like a lung breathing. When the star expands, its light grows dimmer, for its heat is spread across a larger surface. When it contracts, it heats and brightens again, shining with renewed intensity. The cycle is precise, almost mechanical, yet the effect is lyrical. Each pulse is both predictable and profound, a metronome by which the universe keeps time. It was these stars that gave Edwin Hubble the key he needed to unlock Andromeda's true nature. By measuring the rhythm of a Cepheid, astronomers can determine its absolute brightness. Compare that to how bright it appears from Earth, and distance unfolds like a solved riddle. When Hubble identified Cepheids within Andromeda in 1924, he realized they were far too dim to be nearby. The galaxy was not a local cloud of gas within the Milky Way, but an island universe in its own right, millions of light years away. The universe expanded with that discovery, and all because of the steady beat of variable stars. Alongside Cepheids, Andromeda holds other timekeepers. The RR Lyrae stars, older and smaller, pulse with shorter periods, often less than a day. They are ancient relics, found especially in globular clusters, those spheres of stars that date back to the universe's youth. Their flickering light speaks of a different kind of measurement, a lower rung on Hubble's ladder of distance. By mapping them, astronomers trace not only the structure of Andromeda, but also the history of its oldest populations, the first stars it ever formed. And then there are the binaries, stars locked together in orbits so tight that they eclipse each other from our vantage point. Their brightness dips and rises as one passes in front of the other, like two dancers crossing the stage again and again. These eclipsing binaries are less dramatic than supernovae and less grand than Cepheids, but their reliability makes them invaluable. They too help chart distances and reveal the masses of stars. In their quiet, repetitive waltz, they add another voice to the symphony of Andromeda's light. It is tempting to think of these stars as instruments in a vast orchestra, each playing its part. Cepheids with their swelling crescendos, RR Lyrae with their quick staccato beats, binaries with their rhythmic duets. Together, they create a music of light, a hidden song written across millions of years. To observe them is to listen to Andromeda breathe, to feel its pulse across the void. The impact of this realization is both scientific and deeply human. On the scientific side, variable stars have provided the very foundation of modern cosmology. Without them, the distances to galaxies would remain uncertain, the scale of the universe blurred. They are the measuring sticks that allow us to place Andromeda in its proper context, to recognize not just its immensity, but its kinship with the Milky Way. They are the reason we know the universe is vast beyond comprehension. On the human side, they are reminders of rhythm itself, of the universality of cycles. Our own lives are governed by pulses, the beating of our hearts, the rhythm of our breathing, the waxing and waning of the moon, the seasons that return each year. In Andromeda, the stars themselves echo these patterns. It is as if the galaxy itself is alive, its flickering lights mimicking the rise and fall of breath, the expansion and contraction of a chest, the opening and closing of eyes. Pause for a moment and imagine this. Each time a Cepheid star brightens, a message is sent across millions of light years, a signal written in light. By the time it reaches us, centuries or millennia have passed, but the rhythm remains intact, like a heartbeat echoing in the dark. These stars are speaking across time, telling us not only where they are, but also that they are alive in their own way, pulsing with the physics of instability. There is something profoundly comforting in this knowledge. It suggests that even in the vast silence of space, there is rhythm. There is order. The galaxy breathes, and we, small and temporary though we are, can sense it. The flickers are not random noise, but structure, repetition, meaning. They tell us that even in chaos, there is pattern. Even in distance, there is connection. But to see these rhythms, we need more than our eyes. Andromeda is far too distant for its flickering stars to be resolved without tools. For centuries, its variability was hidden, invisible to human perception. Only with telescopes, only with the patient recording of brightness over time, only with the mathematics of light curves could these whispers be heard. Our technology became our ears, extending our senses into realms we could not otherwise touch. And in doing so, it allowed us to discover not just the facts of distance, but the poetry of light itself. The stars that flicker in Andromeda are not anomalies. They are fundamental to the way the universe works. Without them, our map of the cosmos would still be shrouded in fog. With them, clarity emerges, distances unfold, the structure of the universe reveals itself. Their pulses are more than measurements. They are the way the cosmos speaks, a code written in brightness and darkness, waiting for us to learn its language. And so, when you next gaze at Andromeda, remember that beneath its seemingly steady glow lies an intricate symphony of flickers. Cepheids are breathing, RR Lyrae are ticking, Binaries are eclipsing. The galaxy is alive with rhythm, alive with change. It is not a frozen painting, but a dynamic performance, unfolding across scales of time we can barely comprehend. The thought is humbling. From our perspective, bound to the surface of a small planet, the universe can feel static, eternal. Yet Andromeda's variables remind us that nothing is still, that all is in motion, that even stars have their heartbeats. The galaxy breathes, and in that breath lies the key to understanding both its distance and its essence. But the question remains, how do we truly see such distant rhythms, such subtle fluctuations? What instruments allow us to hear the heartbeat of another galaxy? To follow this path, we must look beyond the visible, beyond what our eyes alone can capture, and enter the realm of observation itself. For most of human history, to look at the night sky was to rely on nothing more than the eyes we were born with. Our ancestors gazed upward, seeing the stars as pinpricks of fire, the Milky Way as a pale band, and Andromeda as a faint smudge, barely visible to the patient observer. Those eyes were wondrous in their own right. But they were also bound by biology, by evolution, by limits that did not care for galaxies or the grand scales of space. The human retina is tuned to a narrow strip of wavelengths, a sliver of the electromagnetic spectrum that happens to fall between the ultraviolet of the young sun and the infrared glow of Earth itself. It is beautiful, yes, but partial. Andromeda, however, is not partial. It radiates across the entire spectrum of light, from radio waves many meters long to gamma rays shorter than an atom. To know it fully, we must see with more than our fragile eyes. We must borrow new senses, technologies that extend perception into realms evolution never granted us. Only then does the galaxy open itself, each wavelength peeling back another layer of truth. Take infrared light, for instance, the glow of warmth itself. Our eyes cannot see it, but instruments can, revealing Andromeda in a wholly different way. Its spiral arms, so faint in visible light, shine with clarity in the infrared, for dust that hides newborn stars becomes transparent in this wavelength. Through these borrowed eyes, Andromeda is not a simple disk but a web of structure, glowing lanes of gas and clouds where stars are being born. To study it this way is to glimpse the galaxy's nurseries, the hidden places where suns like ours ignite. Shift further down the spectrum, and the view changes again. Radio waves, long and invisible, wash over us daily, but to a radio telescope, they are a language. Andromeda's radio voice is soft but vast, telling of hydrogen, the most abundant element in the universe. Maps made in radio frequencies reveal an ocean of neutral hydrogen stretching far beyond the visible disk, an invisible halo of raw material that fuels the galaxy's ongoing life. These are its seas, calm on cosmic timescales, though occasionally stirred by the gravitational pull of nearby companions. In radio light, Andromeda ceases to be just a disk of stars and becomes a living reservoir, a system sustained by the quiet abundance of hydrogen. Move upward in energy, and X-rays transform Andromeda into something stranger still. What was once serene becomes violent, peppered with points of furious light. These X-ray sources are binaries, black holes and neutron stars feeding on companions, ripping gas from their surfaces and heating it to millions of degrees. They are wounds and scars scattered across the galaxy, reminders that death and destruction are as essential as birth and renewal. Where our eyes see calmness, X-rays reveal violence. Where we imagine harmony, high-energy light tells a story of hunger. And beyond even this, the universe bends itself into new instruments. Gravitational lensing, the warping of space-time by mass itself, allows Andromeda to distort the light of galaxies far behind it. Through this bending, astronomers can weigh invisible matter, tracing the dark scaffolding that binds it together. In a sense, Andromeda becomes not just an object to observe, but a tool for observation, a natural telescope sculpted by gravity. There are even whispers of more exotic senses, ones we are only beginning to develop. Neutrinos, those ghostly particles that pass through matter almost without interaction, may one day tell us of cataclysms within Andromeda's stars, signals carried directly from their cores. Gravitational waves, ripples in the fabric of spacetime, may arrive from black holes colliding within its arms, faint tremors that carry across the void. Though we have yet to catch such messengers from Andromeda, the possibility remains, a promise of future perception. What all these senses teach us is that Andromeda is not one thing. It is not merely the faint smear of light we see on a clear night, nor even the spectacular spiral captured by modern telescopes. It is a layered being, a composite of truths, each revealed by a different kind of vision. To see it in one wavelength is to know a fraction of its story. To see it across the spectrum is to appreciate its complexity, its multiplicity, its paradoxes. There is something profoundly humbling in this realization. Our human eyes, as marvelous as they are, offer only a shallow glimpse. Without technology, without the ingenuity to extend our senses, we would never have known the galaxy's nurseries, its seas, its scars. We would never have discovered the skeleton of dark matter that holds it together, the violent binaries that burn with invisible fire, the hydrogen that stretches like a hidden ocean. And so our relationship with Andromeda is not merely observational, but collaborative. We build instruments, and in return, the galaxy reveals itself in new ways, always deeper, always stranger. To study Andromeda in this way is also to learn something about ourselves. The fact that we can extend our senses beyond their natural limits is a testament to human curiosity, to the refusal to be confined by biology. A stone tool extended the reach of our hands, a telescope extended the reach of our eyes, a radio dish extended the reach of our hearing. Each act of extension is an act of imagination, a belief that there is more to be known, more to be sensed, more to be understood. And in the case of Andromeda, each extension has been rewarded with revelation. Consider what it means, then, to piece together these views. Infrared shows us the hidden nurseries, radio reveals the oceans of hydrogen, X-rays expose the violent remnants, and visible light gives us the spiral arms in their full glory. Together, they weave a tapestry of understanding. No single vision is enough, no single perspective sufficient. Only by gathering them all do we approach something like truth. And even then, it remains incomplete, for Andromeda surely has more secrets, visible only to senses we have not yet imagined. Perhaps that is the deepest meaning of all. To look at Andromeda with borrowed eyes is to confront the limits of our perception, and at the same time, the vastness of our potential. The galaxy is more than we can ever see with naked eyes, but not more than we can seek. Each wavelength, each particle, each ripple of spacetime is an invitation, a challenge, a reminder that the universe is not made to fit within human senses, but is still within human reach. If only we keep building, keep looking, keep listening. And when we turn those borrowed eyes toward Andromeda, the galaxy becomes a mirror as much as a subject. It shows us not only what lies across the void, but also who we are, what it means to push against the edges of perception, what it means to hunger for more. In the end, to study Andromeda is not just to learn about another galaxy. It is to learn about the human capacity to see beyond sight, to imagine beyond imagination, to find new truths in silence. And yet, after all this, when we compare Andromeda to our own Milky Way, the reflection is uncanny. For in its structure, its rhythms, its scars, we see not just another galaxy, but a twin, a sibling, a mirror image waiting for us in the dark. If you step outside on a moonless night and lift your eyes to the northeast horizon, Andromeda may reveal herself, a faint oval of light just at the edge of human sight. It is easy to mistake her for something fragile, like a wisp of breath on glass. And yet that blur carries a weight that dwarfs our own galaxy. For in many ways, Andromeda is our mirror, her reflection stretched across space, her likeness uncanny yet skewed, as though the cosmos crafted two siblings with the same raw material, but let them grow in different directions. To look at Andromeda is to look at what we might have been, had our circumstances tilted ever so slightly. Andromeda is larger, a disk that sprawls across 220,000 light-years, nearly twice the breadth of our Milky Way. She is heavier too, containing 1 trillion suns, more than twice what our galaxy boasts. Her rotation is swifter, her stars moving through their orbits with a speed that betrays the grip of a massive invisible halo of dark matter. Her core is denser, her central black hole more massive, weighing in at 140 million solar masses, compared to the paltry 4 million in our own galactic heart. By nearly every measure of size, Andromeda is the elder, the grander, the heavier sibling. And yet, appearances deceive. For while Andromeda's skeleton is grand, our Milky Way burns with a livelier spirit. We, the smaller sibling, are more fertile, more restless in our creation. Our spiral arms glow with newborn clusters, nurseries where stars still form with gusto, while Andromeda's rate of birth has slowed. She spins faster, yes, but she creates less. Her heart, vast and ancient, is quieter, while ours hums with greater activity. This paradox, that the larger galaxy is less fertile, reminds us that growth is not always about size. Sometimes it is about rhythm, about cycles of feeding and quiescence, about when gas clouds collapse into stars and when they lie dormant. It is tempting to anthropomorphize these two galaxies, to imagine them as siblings who grew up in the same neighborhood, each shaped by similar forces but carrying their own quirks. One, Andromeda, is the tall, older child, strong but reserved, her youthful energy already spent. The other, the Milky Way, smaller but still buzzing with activity, eager to make more, to burn brighter, at least for now. If the universe is a family, then these two are the closest of kin, forever linked by proximity, by gravity, by destiny. To compare them is also to confront the strangeness of galactic life cycles. Why should Andromeda, with all her mass, all her hydrogen, all her gravity, be quieter in star formation? One reason lies in history. Andromeda's past has been marked by more frequent collisions, mergers that stirred her structure but also heated her gas, making it harder for clouds to collapse and form stars. She has eaten more of her companions, absorbed more dwarfs, digested more matter, and in doing so, she has aged faster. The Milky Way, though no stranger to mergers, has enjoyed a calmer adolescence, conserving more of her cold gas, and so she remains active in her youth. And yet, they are more alike than they are different. Both are spiral galaxies with majestic arms. Both harbor central black holes and halos of dark matter. Both are orbited by families of dwarfs, their satellites trailing like children in tow. Both live within the same local group, bound by gravity in a cosmic dance. They are siblings, yes, but siblings with stories that diverge, siblings who reveal to us that galaxies, like people, are not defined by size alone. The meaning of this comparison is profound. For much of history, humanity believed itself to live in the only galaxy, the Milky Way, a solitary island in an otherwise empty sea. To realize that Andromeda was another island shattered that illusion, and to realize she was larger than us humbled us further. But the deeper comparison is more subtle. Andromeda is not just another galaxy, not just a neighbor across the void. She is a reflection of ourselves, similar enough to compare, different enough to teach. By studying her, we learn not only what galaxies can be, but what ours might become. We glimpse possible futures, possible pasts, possibilities that shape our understanding of cosmic life. Consider what it feels like to look at her light, knowing it left her 2.5 million years ago. In that span, our ancestors were still shaping stone tools, still struggling to master fire. Every photon that enters our telescopes tonight began its journey long before civilization, before agriculture, before written history. To study Andromeda is to study a message carried across aeons, a mirror not only across space, but across time. And in that mirror, we see the differences that matter. She is larger, older, quieter, heavier. We are smaller, younger, noisier, still teeming with life. What does it mean that these two galaxies exist side by side, each the other's nearest great companion? Perhaps it means nothing at all. Mere chance, a statistical inevitability in a universe of hundreds of billions of galaxies. But perhaps it also speaks to connection, to the way gravity binds systems not just within themselves, but to one another. Andromeda is not merely our neighbor, she is our destiny. We are already tied together, invisible filaments of dark matter linking us across the gulf. Their kinship is not simply observational, it is dynamical, inevitable, written into the equations of motion. There is comfort in that inevitability. For as lonely as galaxies might seem in the darkness, the truth is that they are not alone. They are drawn together, paired, mirrored, entwined in dances that take billions of years. And in the case of Andromeda and the Milky Way, the dance is closer than ever, the partners approaching, the steps of their slow waltz visible in the shift of spectral lines. In just a few billion years, that dance will end in embrace, a collision that reshapes them both. But for now, we live in the moment of reflection. We live in the pause before the dance reaches its climax, in the quiet tension of knowing that the mirror across the void is not only our sibling, but our future. Every star we see in her spiral arms is a reminder that we too spin in similar arms. that her structure echoes ours, that her destiny foreshadows our own. Galaxies are more than collections of stars, more than gravity wells, more than halos of dark matter. They are stories written in gas and light, in collisions and quiet births, in hunger and in restraint. And when two such stories run parallel, close enough to compare, close enough to reflect, the meaning is amplified. Andromeda tells us who we are by showing us who we are not. She reminds us that we are not unique, that the universe is full of mirrors, each one slightly warped, each one slightly altered, each one holding up a version of ourselves. And so, as we look at her faint glow, we are reminded of the bond between siblings. Larger, faster, older she may be, but in her reflection, we find companionship. We are not alone in the local group, not adrift in silence. We are part of a family, and in that family, Andromeda is our closest kin. Soon, though, kinship will become collision. The reflection will not remain across the void. It will rush toward us, and the mirror will break. In the far reaches of the future, long after the continents of Earth have shifted into strange and unrecognizable shapes, long after the sun has warmed enough to challenge the persistence of life, a new spectacle will begin to unfold in the heavens. Andromeda, the faint blur that now requires dark skies and patient eyes, will have grown into a looming presence, her spiral arms stretched wide across the firmament. The slow pull of gravity, silent and unstoppable, will bring her closer and closer until she dominates the sky. Humanity, if it endures in some form, will look upward and see not a neighbor across the void, but a tidal wave of stars approaching, a promise of collision written into the structure of space itself. Astronomers have traced the path of this inevitability with careful measurements, tracking the slight blue shift in Andromeda's light that reveals her motion toward us. 4 billion years may sound like forever, yet in cosmic terms, it is little more than tomorrow. Galaxies are restless creatures, bound not by stillness but by encounters. And this is the greatest of all encounters, the merging of two titans in the heart of the local group. Their approach will be slow, their first meeting gentle by human standards. But the consequences will ripple across the stars. It is tempting to imagine collision as chaos, stars smashing into one another in a frenzy of destruction. But this is not how galactic mergers unfold. The spaces between stars are vast, so vast that even when two spirals overlap, the chance of direct impact between suns is infinitesimal. Instead, the collision plays out in subtler but more profound ways. Orbits are stretched and twisted, like dancers flung into new steps. Clouds of gas are compressed, igniting new waves of star formation. The delicate disks of both galaxies are shredded into streams, pulled and tangled until the spirals that define them dissolve. And at the center of it all, the supermassive black holes that anchor each galaxy will begin their inexorable spiral toward one another, a slow embrace that ends in a cataclysm of gravitational waves. The new galaxy that emerges from this union will be something different, something neither Milky Way nor Andromeda, but a hybrid, larger and rounder. No longer a spiral, but an elliptical giant. Astronomers call it Milkomeda, a word that carries both familiarity and strangeness, a reminder that even in transformation, there is continuity. This galaxy will carry the stars of both parents, their histories woven into one. Where once there were two distinct stories, there will be one. Imagine standing on a distant world as this process begins. At first, Andromeda would simply appear larger each night, her spiral arms spreading like wings across the horizon. Constellations once fixed would warp as her stars intermingled with ours. The familiar night sky would dissolve into something alien, new patterns forming, old patterns fading. Over time, as the galaxies overlap, the heavens would blaze with brilliance. Star-forming regions, triggered by the collision, would light up like cosmic fireworks, painting the darkness with blue clusters of newborn suns. The view from any surviving planet would be both terrifying and sublime. A reminder that the cosmos itself is not static, but alive with transformation. Yet even in the midst of this upheaval, most solar systems would remain undisturbed. Planets would continue to orbit their suns, their local gravities strong enough to resist the larger tide. It is the architecture of the galaxies that will change, not the integrity of individual star systems. The drama is grand, but not always personal. To a creature living on a distant world, the danger would not come from crashing into a foreign star, but from subtle shifts. A planet's orbit perturbed by the passing of a massive cluster, a sun flung farther from the galactic core, or perhaps sent drifting into intergalactic space, cut loose from its family. The greatest drama, though, unfolds in the centers. There, Andromeda's black hole, a behemoth of 140 million solar masses, and the Milky Way's smaller but still formidable black hole of 4 million solar masses, will begin their long courtship. Drawn together by gravity, they will orbit one another in tightening spirals, their dance radiating gravitational waves into the cosmos. For millions of years, this silent music will ripple across space-time, until at last the two black holes merge into one, unleashing a final crescendo of gravitational energy that could be detected across the universe. The new singularity, far more massive than either parent, will become the anchor of Milkomeda, a heart forged from union. The meaning of this collision is both scientific and philosophical. It shows us that galaxies are not eternal structures, but dynamic, evolving beings. It reminds us that endings are also beginnings, that destruction is inseparable from creation. The spirals of the Milky Way and Andromeda, so graceful now, will not survive the merger, but in their place, new stars, new worlds, and new possibilities will arise. The night sky will no longer be ours, but it will belong to whatever life survives to see it, and to them, it will be just as natural, just as beautiful as ours is now. Perhaps there is something comforting in this inevitability. We often think of collisions as catastrophes, but in the language of galaxies, collisions are how growth occurs. The great elliptical giants that sit at the centers of clusters bloated with stars are the products of countless such mergers. Milkomeda will join their ranks, a survivor and a witness to the passage of time. If there is intelligence then to gaze at the heavens, it will not remember that the sky once had constellations called Orion or Cassiopeia. It will know only the grandeur of a sky remade. And if we think even further, beyond human time, beyond the lifespan of stars, we can see how fleeting even this collision is. 4 billion years may mark the merger, but within a few more billions, the stars born in its wake will age, the gas will thin, and Milkomeda will settle into a quieter existence. The elliptical giant will shine, yes, but with less youth, less vigor, until at last its stars grow dim. In that distant age, the collision will be a memory, written in the distribution of stars, in the mass of the central black hole, in the shape of the remnant galaxy. Yet for us, now, it is a story of anticipation. To know that our galaxy will collide with Andromeda is to feel a sense of destiny, a reminder that we are not isolated, not immune to the grand flows of cosmic time. We are part of a narrative that stretches beyond our own existence, a narrative written not just in light years, but in billions of years. It is humbling, yes, but also strangely reassuring. We are not outside the story, we are within it. And so the vision lingers. Two spirals approach, their arms outstretched, their futures entwined. The Milky Way and Andromeda, siblings across the void, will soon be siblings no more. They will become one, their identities dissolving into a larger whole. And for those who live to witness it, the night sky will become a canvas of transformation, a reminder that even the most familiar heavens are never fixed, never eternal, but always changing. And then comes the question that stirs beneath all of this grandeur. What happens to life caught within the storm? When two galaxies collide, the first impression is one of ruin. Spiral arms are shredded, delicate patterns of stars are stretched into ribbons that vanish into intergalactic space, and the symmetry that once defined them is erased. To imagine such a fate for the Milky Way and Andromeda is to picture a slow unmaking, an erasure of all that feels familiar. Yet within that chaos lies a profound truth. Destruction is not the final word. Collision is also creation. It is a crucible in which raw materials are gathered and reshaped, a process that births as much as it consumes. The gas clouds that now float serenely through both galaxies will not remain serene. Gravitational tides will stir them, pulling them into filaments and knots, compressing them until they collapse. Where collapse occurs, stars are born, hot and bright and blue, consuming fuel at furious rates. These starbursts will erupt like cosmic fireworks, clusters of suns igniting all at once, their light spilling across the newborn Milkomeda. The collision will not merely scatter the past, it will forge the future in torrents of light. Some of these stars will live short, furious lives, burning through their hydrogen and helium in mere millions of years, before exploding in supernovae that seed their surroundings with heavy elements. Others will be gentler, smaller, longer-lived, and it is these that offer the most promise for renewal. Around such stars, planets will coalesce, gathering from the enriched material released by their predecessors. Iron, carbon, oxygen, silicon, nitrogen, all will be more abundant than before, mixed into the disks from which new worlds are formed. If today we marvel at Earth, a planet built from the ashes of earlier generations of stars, then in Milkomeda there will be countless Earths waiting to emerge, each with its own potential to cradle life. The habitable zones of these systems, those delicate rings of space where liquid water can exist, will be shaped anew. Some will orbit red dwarfs, offering long stretches of stable warmth. Others will circle yellow suns like our own, balanced between fire and frost. Still others may exist around stars very unlike ours, in configurations that we can scarcely imagine. Life, if it emerges, will not be bound to familiar forms. The chemistry of survival is broad, the possibilities vast. What matters most is the abundance of material and the time to experiment, and collisions provide both. Not all renewal is tied to stars. The violence of merging galaxies will cast some planets adrift, severing their ties to suns and sending them wandering through the darkness. These rogue planets may seem like failures, worlds denied the light, but even they may carry secrets. Beneath thick blankets of ice, under atmospheres rich in hydrogen, or in oceans heated by internal radioactivity, life could endure in silence. They may never see starlight again, yet they could be cradles for creatures that thrive without the sun. If they exist, their journeys will be long, their stories strange, but they too are seeds scattered by collision. For the beings who might one day look up at the transformed sky, the changes will be profound. The familiar constellations will dissolve, replaced by new patterns born of the mingling stars. What once seemed eternal will be revealed as temporary, and that revelation may reshape how civilizations understand themselves. If intelligence survives, it will learn that home is not a fixed structure, but an evolving one, that the galaxy itself is alive with cycles of death and rebirth. The night sky will not be lost, only rewritten. This cycle of destruction and renewal is not unique to our future. It has always been the way of galaxies. The Milky Way itself bears scars of past mergers, streams of stars that are the remains of swallowed companions. Andromeda too has consumed many smaller galaxies, their remnants orbiting still as clusters and faint arcs. What we call collision is in truth continuity. It is how galaxies grow, how they renew themselves, how they create the conditions for new life to arise. The union of the Milky Way and Andromeda will be one more chapter in that story. A chapter vast beyond comprehension, yet as natural as a heartbeat. To reflect on this is to confront a paradox. On the one hand, the collision means the end of everything we recognize. The spiral arms of the Milky Way, the Great Dark Rift, the bright sweep of stars across summer nights, all will vanish. On the other hand, it means the beginning of things we cannot yet picture. New skies, new stars, new worlds. For every loss, there will be a gain, though not for us. For life that comes after, the merger will not be an ending, but a gift, a chance to arise in places where before there was only emptiness. There is poetry in imagining that Earth itself, or its descendants, could witness this rebirth. Perhaps by then, our planet will be long gone, its oceans boiled away by the brightening sun, its rocks ground down into dust. Perhaps humanity, if it survives in some form, will have scattered among the stars, watching the collision unfold from distant vantage points. If so, we will see our galaxy's death not as a tragedy, but as part of a cycle that ensures others will thrive. The cosmos wastes nothing. It transforms. When two galaxies collide, the universe does not end. It begins again, in forms both familiar and alien. Every starburst, every new planet, every rogue world wandering through the void is a continuation of that cycle. The end of one sky becomes the foundation of countless others. We may not live to see them, but the seeds will be planted, and in the fullness of time, some will grow. And so, the collision of the Milky Way and Andromeda is not simply a tale of destruction, but of renewal. It is a reminder that even in the grandest scales, life and possibility arise from turmoil. The galaxies will merge, yes, but from their union will come new stars, new worlds, and perhaps new forms of awareness to look up and wonder. The story will not stop with us, and yet a deeper question lingers. All this renewal is potential, possibility, promise. But what of the present? What if Andromeda already carries the spark we seek? What if the question of life is not only a matter of the future, but of now? 1,000,000,000,000 stars. The number itself resists comprehension, slipping through the mind like sand through open fingers. Yet within that immensity lies a simple, almost irresistible question. How many of those suns bear living worlds? If Earth arose around a single ordinary star, orbiting in a galaxy of 400 billion others, then what might await in Andromeda, where the star count more than doubles, where time has flowed for billions of years, and where conditions are as varied as imagination allows? Andromeda's wealth of stars makes it fertile ground for possibility. Its outer arms host young, metal-rich suns, enriched by generations of supernovae that seeded their surroundings with heavy elements. Metals, in astronomical terms, are more than mere ores. They are the foundations of rock, water, and life. Without carbon, oxygen, silicon, iron, and nitrogen, there are no planets like ours, no oceans to cradle life, no atmospheres to protect it. In Andromeda, these ingredients exist in abundance, scattered like seeds across a vast celestial plain. Around countless stars, protoplanetary disks swirl, grains of dust colliding and clumping, spiraling inward and outward until they assemble into worlds. Some will remain barren, lifeless stones adrift in space. But others may become cradles of warmth, oceans and skies drawn into balance by distance, mass, and chemistry. Life itself may take forms beyond our narrow expectations. On Earth, it has been shaped by carbon, water, and the gentle moderation of the sun. But other chemistries are possible. Silicon, abundant in the cosmos, could build chains of molecules, forming the skeletons of exotic organisms. Ammonia could replace water as a solvent, or methane seas could harbor creatures adapted to cold far beyond anything we can endure. Even the magnetic storms of a pulsar or the glow of a red giant might fuel ecosystems strange and alien. Evolution does not ask permission. It only seeks footholds, wherever the conditions allow. It is humbling to imagine how many such experiments have been attempted in Andromeda. For more than 10 billion years, stars have been forming and dying there, planets coalescing and dissolving, oceans boiling away, atmospheres torn by flares, surfaces remade by volcanic fire. Some of these worlds may have reached stability long enough for life to begin. On Earth, it took less than 500 million years for simple cells to arise once conditions were right. If that pattern holds elsewhere, Andromeda may be rich with microbial worlds, planets covered in mats of strange photosynthetic organisms, or oceans teeming with unseen swimmers. Others, given enough time, may have produced complexity, creatures that see, that move, that sense the rhythms of their skies. And perhaps, somewhere within that trillion-star sea, intelligence has bloomed. Civilizations might have arisen in ages long past, when Earth itself was only a world of microbes. They may have watched their skies, charted the patterns of stars, and wondered at the faint smudge of the Milky Way shining across the void. Some may have reached out, building machines to listen, to send signals, to cross gulfs we still consider impossible. Others may have turned inward, living and dying without ever leaving their home. There is room in Andromeda's immensity for countless histories, each beginning, flourishing, and ending in silence. The thought stretches the mind until it aches. To realize that we may not be alone, not even in our own cosmic neighborhood, is to confront a profound humility. For the light from Andromeda takes more than 2 million years to reach us. Any civilization we glimpse, should we ever glimpse one, may already be gone. We look into their deep past, as they, if they look back, see ours. Communication is nearly impossible. Contact, in any ordinary sense, cannot happen. And yet, the possibility remains intoxicating. To know that others have walked their own paths, struggled with their own questions, perhaps even stared into their own night skies and dreamed of neighbors, would be to realize that life is not a singular accident, but a chorus. There are those who wonder whether Andromeda holds not only life, but minds capable of shaping stars themselves. Could there be civilizations advanced enough to harness the energy of suns, to build colossal structures like Dyson spheres, to manipulate orbits, or to sculpt light into signals across the void? If such entities exist, their signatures might already be hidden in the data we collect, buried among the stars, faint but waiting. We may not yet know how to read them, but the search itself is a form of hope, a way of whispering into the darkness. We are here, and perhaps so are you. Even if no civilizations remain active, the mere possibility that they once existed alters how we see ourselves. We are not the inevitable crown of evolution, but one experiment among countless others, fragile, temporary, and precious. The silence we hear may not mean absence, only distance, or the fading echoes of voices long gone. When we gaze at Andromeda, we are not only looking at stars, we are looking at a mirror of our own potential, our own destiny, and our own transience. Take a moment to imagine it. A planet orbiting a star in Andromeda, a world with oceans and continents, with storms rolling across plains and mountains reaching into alien skies. Perhaps on that planet there are beings, curious and restless, staring upward at their faint smudge of a Milky Way. Perhaps they too wonder if someone is watching them. Between us lies a gulf of millions of light years, but in the shared act of wonder, the distance closes. Two galaxies, two sets of minds, united by curiosity, divided by time. And this leads to the most tantalizing question of all. If life exists in Andromeda, if civilizations rise and fall within its vastness, could they one day reach across the void? Could technologies far beyond our imagining bridge that abyss? Or will the two galaxies have to collide 4 billion years from now, before life from one can finally touch the other? To dream of Andromeda is to dream beyond scale. The galaxy hangs in our sky as a faint blur of light, yet its distance mocks every notion of travel we possess. 2.5 million light years, numbers so vast they eclipse comprehension. Even at the speed of light, which no human vessel will ever attain, the journey would last longer than the history of our species. Against such gulfs, the imagination falters. And yet, we imagine. The Andromeda Protocol is not a blueprint written in equations or locked in the vaults of engineers, but a story humanity tells itself about what might be possible. The first chapter is humble, yet bold. Machines. Long before any human body dares to drift between galaxies, our machines will go. Robotic explorers, tireless and patient, are the natural pioneers. They do not age, they do not hunger, and they can sleep for epochs. A craft no larger than a sail, driven by the steady pressure of starlight or the fury of lasers, could one day slip into the intergalactic dark. It would not carry humans, only our questions etched in circuits and code. Its journey would not be measured in years, but in millions of years, a message cast into the sea of time. But imagination seldom rests at patience. If machines can wander, why not us? The dream of generation ships, colossal arcs drifting through the void, haunts science fiction and whispers to futurists. Inside these ships, societies would bloom and fade, each new generation inheriting the voyage as a birthright. Children would be born to corridors lit by artificial suns, their only horizon the hull of the vessel itself. For them, Earth would be a myth and Andromeda a destiny. They would never arrive, not in a single lifetime, but the ship itself would embody continuity, a seed of humanity cast into intergalactic soil. Whether it reached its destination or not, the act of leaving would be a declaration that distance does not define us. Yet there are those who imagine an escape from flesh entirely. Why carry bodies across the abyss when minds can be distilled into information? Consciousness, reduced to patterns of neurons and sparks, could be transmitted as streams of data, encoded into beams of energy, racing faster than ships ever could. Across the gulfs, these whispers of self might be received by waiting machines, given form anew. In this vision, humanity becomes less biological and more like the messages it sends. We do not cross space as bodies, but as light. Of course, such ideas strain the limits of plausibility. Even beams of light take millions of years to cross the distance, and whether a mind could endure such exile remains uncertain. Yet the power of the Andromeda Protocol is not that it offers guarantees. It is that it gives us permission to dream. Once, heavier-than-air flight was impossible. Once, rockets leaving Earth was fantasy. Once, the moon was too far, Mars unthinkable. What seems impossible today may be obvious tomorrow, and what seems unthinkable may one day feel inevitable. The gulf to Andromeda is vast, but imagination is larger still. To contemplate this protocol is to confront the deeper truth of distance. Perhaps the real gap is not measured in light years, but in vision. To imagine another galaxy as a place we might one day reach is to break the boundaries of the mind itself. Even if humanity never builds the sails, the ships, or the transmitters, the very act of picturing them stretches us. It reminds us that the universe is not confined to what we see, but what we dare to imagine. And there is a subtle, almost tender irony in this dream. For all our boldness, the Andromeda Protocol is not only about crossing. It is also about continuity. To plan such journeys is to whisper to ourselves that humanity may endure, that we may still exist in millions of years, curious, restless, unwilling to accept boundaries. It is not only about reaching Andromeda, but about surviving long enough to try. Imagine, then, the quiet awe of a future being, whether human, machine, or something else entirely, standing upon a new world orbiting a star in Andromeda. The sky above them would blaze with unfamiliar constellations, yet faint in the distance would hang the Milky Way, reduced to a smudge of light, just as Andromeda appears to us now. For them, our galaxy would be the unreachable dream, the myth across the void. In their wonder, they would mirror us, just as we now mirror the questions of those who gazed upward centuries ago. The Andromeda Protocol is, at its core, less about engines and ships than it is about perspective. It teaches us to see not only where we are, but where we might be. It dares us to imagine a horizon beyond horizons, to refuse confinement by scale, to believe that the act of dreaming itself is a form of travel. And yet, as we allow this vision to unfurl, another question slips into the silence. What if such journeys have already been made? What if, among the trillion stars of Andromeda, civilizations older and stranger than ours have already reshaped their galaxy, leaving behind signatures too vast or subtle for us to yet recognize? To look at Andromeda is to stare into a sea of suns, a trillion lights scattered across a disk so immense it defies imagination. Yet within that immensity hides a deeper possibility, that not every glimmer we see belongs to nature alone. Some might be shadows cast by intelligence, by works of engineering so vast they rival stars themselves. This is the thought that has haunted astronomers and dreamers alike. The idea that within the quiet shimmer of another galaxy could lie the fingerprints of minds far older, far stranger, and far more capable than our own. Among the most evocative of these imagined creations is the Dyson sphere, not a solid shell encasing a star, as science fiction once loved to depict, but a swarm of satellites and structures orbiting in intricate harmony, capturing the star's energy and redirecting it for use. To us, a sun is a distant blaze, nourishing yet untouchable. To a civilization with millions of years of advancement, it may be nothing more than a power source, one to be harnessed fully. The signature of such a construct would not be visible in ordinary light, for the star would appear dim or hidden. Instead, it would radiate in infrared, glowing faintly with the waste heat of civilization. Searching Andromeda for these unnatural patterns is like seeking the warmth of fires in a darkened forest. The galaxy is so vast that such signs, if they exist, might already be recorded in our data, awaiting discovery. Other imaginings push further still. A stellar engine, a device designed not only to capture a star's energy, but to move it, is a concept born of both ambition and necessity. Galaxies themselves shift and collide, but what if a civilization refused to be carried along blindly? By directing the momentum of suns, by turning stars into engines, entire regions of a galaxy could be shepherded, guided, and sculpted. To us, this seems unthinkable. Yet when we consider the sheer length of cosmic time, billions upon billions of years, it is difficult to declare anything impossible. What may seem extravagant is, in that scale, no stranger than our own ancestors chipping flint to light fires. Then there are world rings, vast structures encircling stars, or even black holes, to create artificial habitats. These are dreams of abundance, where life is not confined to a fragile planet, but expanded into engineered horizons. Imagine billions of beings walking across the inner surface of a ring so wide that the curve of its structure would be invisible, its sky filled not with stars, but with the glow of artificial suns suspended above. Such creations would leave traces too. Irregular motions of light, strange eclipses, odd shadows against the galaxy's brilliance. The search for these anomalies is not idle speculation. Already, astronomers scan galaxies for excess infrared radiation, for stars whose dimming is irregular, for movements that cannot be explained by nature alone. Most findings resolve into dust clouds, binary companions, or ordinary astrophysical quirks. But each mystery that resists explanation carries with it a whisper. Perhaps we are not only studying galaxies, but reading their histories. Histories that might include architects as much as accidents. To hunt for these megastructures is to look for footprints in starlight. The scale of the task is overwhelming, for the forest of Andromeda contains 1 trillion trunks, each a star with its own branches and roots. Somewhere among them may be a trail, faint and fragile, a mark left by beings who have learned to weave suns into tools. Whether we find it tomorrow, in a century, or never, the search itself transforms us. It forces us to see Andromeda not only as a natural wonder, but as a canvas that may already be inscribed with stories beyond our own. There is a haunting beauty in this possibility. For if such civilizations have arisen in Andromeda, they are likely older than us by millions, perhaps billions of years. Their works would not be built for us, nor even be comprehensible to us. They might already be abandoned, relics drifting in space, their creators long gone. Or they might still be active, their scale so immense that entire constellations bend to their will. To look for them is to admit that we are small, but also to acknowledge that we may not be alone in the desire to shape and to endure. And yet, for all our searching, the galaxy remains stubbornly silent. No clear Dyson spheres, no obvious stellar engines, no unmistakable world rings. The silence is as much a mystery as any discovery would be. It forces us to ask whether advanced civilizations are rare, whether they hide deliberately, or whether their traces are subtler than we can yet imagine. Perhaps we are not looking with the right instruments, or not asking the right questions. Perhaps intelligence always burns brightly and briefly, leaving little more than whispers that fade into the cosmic background. Still, the search continues, for in every spectrum of light, in every flicker of data, lies the potential for revelation. We listen not only for signals, but for patterns in the chaos, for deviations from the ordinary that hint at the extraordinary. Each observation of Andromeda is not just an act of science, but an act of wonder, a willingness to believe that the galaxy may be more than stars, gas, and dust. In the end, the search for megastructures is less about certainty than about possibility. It teaches us to widen our eyes, to consider scales of ambition that stretch far beyond our own. Even if Andromeda hides no such wonders, the act of looking reshapes us. It reminds us that intelligence is not bound by planet or body, but by imagination. What we seek in others is also what we seek in ourselves. Proof that minds can endure, can create, can leave traces that outlast their own brief flickers. Andromeda may be silent, or it may be humming with works too vast for us to yet comprehend. Either way, the shadows we imagine across its stars tell us as much about ourselves as about what may be there. We search because to search is to hope, and to hope is to belong to a cosmos still full of mystery. And yet, even with all the tools we wield, all the dreams we cast upon the galaxy, many questions remain unanswered. For Andromeda still holds secrets deeper than structures, mysteries that lie not in what civilizations may have built, but in what the universe itself has hidden. Andromeda hangs in the sky as both presence and puzzle, a galaxy so vast that to study it is to engage in a conversation with mystery itself. For all the progress we have made in charting its stars, mapping its spiral arms, and imagining its collision with our own Milky Way, the deeper truth is that Andromeda remains an enigma. Beneath its brilliance lie riddles that taunt us, questions that persist no matter how many telescopes we point at it or how many simulations we run. In its silence, Andromeda reminds us of the limits of knowledge, and in that same silence, it calls us to press forward. One of the greatest of these riddles surrounds Andromeda's dark matter halo. What we see, the glowing disk, the sparkling stars, the bright nebula, is only the surface, the faint outer layer of a far larger structure. The galaxy's true mass, perhaps as much as 9/10 of it, is invisible, locked in a substance we cannot touch, cannot directly detect, yet whose presence is undeniable. Stars orbit faster than they should, clusters remain bound when they ought to drift apart, and the overall weight of the galaxy defies explanation without invoking this unseen matter. To gaze at Andromeda is therefore to confront a ghost, a shadow that outweighs the visible light. We do not yet know if this dark matter is made of undiscovered particles, or if it demands a revolution in physics itself. What is certain is that Andromeda's halo is immense, perhaps stretching far beyond its luminous arms, shaping its evolution in ways we are only beginning to grasp. Then there are its globular clusters, those ancient spheres of stars that swarm like bees around the galaxy's edges. Each cluster contains hundreds of thousands of suns, tightly bound, many older than the spiral arms themselves. To study them is to peer back into cosmic history, to glimpse the conditions of the early universe. Yet here, too, lie questions. How did so many clusters form? And why does Andromeda seem to host more than the Milky Way? Some theories suggest it consumed smaller galaxies, cannibalizing them and absorbing their clusters into its swarm. If true, then each cluster may be a relic, a fossil of a devoured companion, carrying within it the memory of collisions long past. Others hint at processes we do not yet understand, mechanisms of star birth and clustering that have no easy parallel in our own galaxy. In these clusters, we see both survival and mystery, light that has burned for billions of years, whispering secrets we have yet to decipher. The disk itself presents another puzzle. Andromeda's rotation is not as smooth as one might expect. Its stars and gas clouds move in patterns that hint at disturbances, ripples, and asymmetries. Some astronomers believe these are scars of past encounters, marks left by galaxies that brushed too close or were swallowed whole. Others suspect internal processes, waves of density rippling outward, reshaping the spiral structure. The truth may be both or neither. What we know is that the disk is not a simple, serene whirlpool of matter, but a dynamic and restless structure, one that carries with it the memory of every interaction and every collision. To read its motions is to try and reconstruct a biography written in starlight, one with chapters missing and sentences obscured. New tools promise to sharpen our vision. The James Webb Space Telescope has already begun probing Andromeda in infrared, revealing details hidden behind dust, exposing the cooler stars and faint structures that Hubble could not fully resolve. Ground-based observatories, equipped with adaptive optics and vast mirrors, continue to peel back layers of detail. Artificial intelligence, trained on mountains of astronomical data, helps us recognize patterns too subtle or complex for human eyes to parse. And still, the mysteries multiply. Each answer uncovers more questions. Each discovery widens the horizon of the unknown. Perhaps this is the truest meaning of Andromeda's silence. It is not empty, not barren, not mute. It speaks in riddles, in half-truths, in signals that demand both patience and humility. To confront those mysteries is to admit that we are only beginning to scratch the surface, that the universe is deeper, stranger, and more inexhaustible than any single generation of thinkers can hope to master. Yet there is beauty in that incompleteness. Andromeda becomes not just an object of study, but a mirror. In its bright arms, we see reflected our own questions, our own longing to know more, to push further, to expand the circle of understanding. It challenges us, daring us to imagine new instruments, new theories, new ways of perceiving. It promises that the search itself is worthwhile, that even if some mysteries remain forever beyond us, the act of seeking brings its own kind of revelation. One day, perhaps, our descendants will know the answers we do not. They may map the dark matter halo in detail, chart the orbits of every globular cluster, reconstruct the full history of Andromeda's collisions, and trace its evolution from birth to present. Or perhaps they, too, will encounter new enigmas, questions that multiply no matter how deeply they probe. Either way, the search will continue for as long as minds exist to wonder and to seek. And so, Andromeda endures as puzzle and promise. Its riddles remind us of how far we have come and how far we have yet to go. Its silence is not a void, but a challenge, inviting us to listen more carefully, to look more deeply, to imagine more boldly. And now, as our journey through its light draws to a close, we too must drift towards silence, carrying with us both the weight of its mysteries and the promise they hold. For the end of one story is always the beginning of another, and the stars of Andromeda will continue whispering their questions long after we have gone.